everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Jonathan, who has completed the course Linux Basics for Robotics. So, as always, we'll begin by seeing a demonstration on the real robot. So we'll see his code base running on the real robot, and then we'll get into the details about how he managed to do his project. And then towards the end, we'll get to ask him a couple of questions. So I will now hand over the platform to him so he can begin his presentation. All right, Jonathan, when you're ready.
Okay. So I've started the simulation, as you can see. I've run the interface, robot interface Python script.
Just hang on, Jonathan.
And now I'll run my...
just hang on one sec. I think we probably have got difficulties with visuals here.
Okay.
Alright, so what would be easier is maybe let's restart this to see if it can have clear visuals as we want.
Should I stop screen sharing and then share again?
Can you try that again? Yeah, you can. Let's... I think once it fails, then I might have to reboot everything. So just hang on. Oh man.
It's not going well for us today, is it?
It's not really in our favor. Going somewhere, so just hang in there.
So just what, sorry?
Just hang on. I will let you know to continue with your presentation. I just want to...
Okay.
Alright. Okay, yeah, we can proceed.
Okay, excellent. So I've started the simulation and then the robot interface Python script, and now I will run my obstacle avoider bash script.
Okay.
It's going to print out the readings from the sensors. It will be 1 if it's well, true or false, depending on whether or not it's within the threshold. And then if it detects something on the left but not on the right, then it should turn right. Otherwise, and vice versa. Otherwise, it'll move forward until it encounters an obstacle.
All right.
So when it reaches this wall, what it should do is it should detect that the wall is closer than the threshold value, and then it will 0.3.
Oh, 0.3. Okay, all right.
And then it will check that the right direction has more space than the left direction, and then it should turn right.
Okay, so it's still trying to avoid the wall. Okay.
Yep. The cycle time is quite long.
Okay. What did you use for it?
What did you use for what? Sorry.
Your cycle time. Oh, you're using the native one that came with the script.
Yeah.
Okay.
Using the native one.
All right. All right. All right. All right. Oh, now it's moving. There we go.
Yep. An obvious improvement to the algorithm would be to have it constantly checking the distances so that it doesn't have to stop and recalculate calculate every time.
Right, I would agree, yes.
But with this being a naive approach for the purposes of the Linux tutorial,
Mm-hmm.
it's,
Yeah, true. I would agree. Very good insight. All right, now it's stopping to. Okay.
uh, it'll keep moving forward, and then it should detect one of those obstacles on the right, and then it will turn left a bit.
Okay, I see. I see.
Like that.
Mm-hmm.
And eventually make its way around.
It's fine. So I think for now let's get to the real robot demo. So you can stop this and then get your code base to run on the real robot now.
Okay, so now I will run the real robot get up bring up script after I connect to it.
Mm-hmm. It's really taking its time, right?
Yeah.
Okay.
I think when I time it when I tested it earlier, it took 15 minutes to do a full loop.
Okay, I see. Alright, so we've seen it avoid a wall. We just want to see it avoid any of the obstacles in the center there.
Yeah.
Okay, okay. That's pretty good. Alright. I think without further ado, can you walk us through your code base? We can leave this one
Yep.
trying to complete the loop and then we'll return to it in about a couple of minutes later.
Oh, keep it running.
Yeah, just keep it running for at least maybe 2 or 3 more minutes.
Okay, sure.
So,
Okay.
are you gonna use any
I'll
slides
start
or?
with. No, I'll just go through it if that's okay.
Yes, that's fine. That's fine.
So I'll go over a high level first. S- So we obviously we source the robot functions so we can uh, understand, or so that we've got access to the different things that the robot can do. So if we go into robot function, it is just an interface layer with the robot interface. So that runs all of our movement commands and such. We define our variables, and I've defined a function for implementing moving forward, turning left, or turning right. And in each of those, they will set an angular velocity, or in the case of moving forward, it sets a linear velocity. It sleeps for some amount of time while it does its movement. In the case of the forward motion, that time to move is set by another function.
Okay.
And then we'll set the velocity back to 0.
All right. All right.
This clamp to 0 function is just to prevent a situation where bad values would give us a negative time for the time to move.
Okay, if you
So
encounter
that's
situations
just
where that actually happens, or you just put that as a guide.
it's just as a safeguard.
Okay, okay.
But
I'm thinking you have had to have encountered somewhere in your code base when you're writing that you thought, oh, this might actually give a negative value.
yeah. Where have I used that function?
Oh, maybe if you do come across it as you go, I think you can. I just highlight.
Yeah,
Yeah.
yeah, sure. So I start a loop, and at the start of the loop, I collect values into variables for each of the ranges. For these ranges are preset positions for the LiDAR. And then I set some variables to tell me if the it's within the range of the threshold that was set for each of those angles. I print those scans so that we've got some feedback in the command prompt, and then here I start my actual logic. And what that does is it checks if it's fully blocked on all sides, or all, front left, front right, and front, then it will check whether or not the left range or the right range is further, and it'll go to whichever direction has more space.
Okay.
If only the right is free, then it turns right. If only the forward is free, as in it's in a corridor, then it'll keep moving forward. If only the left is blocked, then it'll go right. If only the left is free, then it'll go left. And if only forward is blocked, then again it will check the direction has more space and go that direction.
All right.
And finally,
okay,
yeah,
go ahead.
Basically it just checks which way it can go.
Okay, all right. Let's just check our real robot to see if it has completed the loop. Not yet. Yeah, but it's fine. It's giving us a track of where it's been, so it's fine. I think we can terminate it now.
Okay. And then under the robot statistics, I just collect the data from the periodically from the API using the robot functions, which references the robot interface, and then I just, for each of the metrics of interest, I just echo that to the terminal.
All right. So you're not doing any processing with this script. You're just echoing what the parameters that you're getting from the robot. Okay. All right. I see. All right. Anything else?
No, that's it.
That's it. All right. All right. Okay. All right. So just a couple of questions. Can you?
Yep.
Can you explain a little bit why you have to make your, what can I say? Let's just say your execution thread sleep. For example, when you set velocities to a particular value, why do you have to make it sleep? Can you elaborate what's the logic behind that?
Yeah. So the logic behind that in this naive example is that if I don't make it sleep, then I'll be setting the velocity and then immediately setting it back to 0, and it won't go anywhere.
Right. Okay.
In a less naive example, rather than sleeping, I would use timers in a real-time operating system, so that it can do background operations while it's moving rather than stopping the whole process.
Right. So that means that also puts a precondition on you knowing for how long you'd want the robot to do that particular movement, for example, right?
Yeah.
Okay. All right. Okay. That's understandable. All right. So.
And of course, in that situation, I would also have some watchdogs that will check if I'm about to crash, then interrupt the movement process and set my velocity to 0, just in case.
True. Okay. All right. I like that. Thank you very much. Very clear. Okay. So I also did see you use the BC, right, in your base script. Can you explain what that is and what is it responsible for, particularly when you do processing of some numbers?
Yep, sure. That's BC. That's basic math,
Mm-hmm.
I believe. Where have I used it? So it just tells it to take this string and to process it as an equation in a calculator, and then it returns the result.
Mm-hmm. Mm-hmm.
So here we've got two variables, um, and it takes that string and pipes it into the basic calculator
Mm-hmm.
um,
And the flag that's given there,
utility.
and that one, yes.
Um, right. Ooh, if I can remember. I don't recall.
All right. It's just to process floating point numbers. So your basic calculator would mostly,
Ah,
yeah,
right.
would work with
Yeah.
integers, but that flag tells it to um, rather
Okay.
process floating point numbers. So yeah,
Yeah. Okay. So otherwise it would be truncated.
something like that.
That
Yeah,
makes sense.
exactly. Yeah. All
Yeah.
right. So on to the next question. Can you, since we are talking about Linux, right? Can you tell me
Yep.
what is the main difference between Control Z and Control C, for example, right?
Yep. So Control C will terminate a foreground process,
Mm-hmm.
but Control Z will suspend a foreground process.
All right, all right. And then if you want to bring it back to the foreground after using Control Z, how would you do it?
Uh,
It's
BG.
yes, very well done. Yeah, that's the one. All right. I think that's it on my end in terms of questions. So thank you very much for a wonderful presentation, Jonathan.
Okay.
Um,
Thank
so
you for your time and patience.
all right. Sincerely apologize for the glitch at the beginning, but yeah, we'll try to get it going smoother next time. All right.
Yeah.
So let's wrap it up here, and I say just hang on for me, please.
Yep.
All right. All right, everyone. So this was Jonathan's presentation. Congratulations to him, and would like to encourage all those of you who would like to give a test or try get some of the projects that we offer certificates on